Welcome to Spring LIB.
This question is about outboard motor, and then inside the motor, gear A, which is connected on the drive shaft, is matched with gear B. Gear B is on the propeller, and then we are given that the radius of gear A is 0.7 inch. Gear B, radius of gear B is 1.4 inch. The angular acceleration of gear A is given to be 300 square root t. In this question, we want to find the magnitudes of the velocity and acceleration of points P located on the tip of the propeller. Okay, so before we look at the propeller, we first need to find the angular velocity for gear B. Okay, so we are given that 3 alpha A is 300 square root t, and omega A would be integrate alpha A dt. Initially it's at rest, so it's just direct integration. Okay, 300 square root t prime dt prime, we get integrate from 0 to t, we get 200t to the 3/2. And then at t equals to 0.75 seconds, we found that omega A is 200 times 0.75 3/2. This is 130 radians per second. And then alpha A will just be 300 times 0.75 to the half, and then this is 260 radians per second square. Okay, so since B is meshed with A, which means that omega B RB equals to omega A RA, or similarly the angular acceleration alpha B RB equals to alpha A RA. Okay, the tangential speed must be the same, the tangential acceleration must be the same. Okay, so here we can find omega B to be RA divided by RB times omega A. So 0.7 divided by 1.4 times 130. So this is 65 radians per second. And then alpha B is similar relationship, RA divided by RB times alpha A. So here you can see that it's just half times 260, you get 130 radians per second square. Okay, so now we can proceed to find the magnitudes of the velocity and angular and acceleration at point P. Okay, so this is just a schematic of the propeller. Point P is 2.2 inch from the center. Okay, so to find the speed at point P will be Vp equals to omega B times Rp. Okay, so this is equal to 65 times Rp is in inches, 2.2 inch, convert to feet, divide by 12, so you get 11.9 feet per second. Okay, and then to find the acceleration at points P, we first need to find the tangential acceleration. Okay, so this is alpha B times Rp. So 130 times 2.2 divided by 12 to convert into feet. So this is 23.8 feet per second square. And then the normal component will be omega B square times Rp. So this is 65 square times 2.2 divided by 12 to convert into feet. So we have 773 feet per second square. Then the acceleration at points P would be the square root of the squares of the components. Okay, so sum the squares. So 23.8 square plus 773 square. Take the square root, and you get 774 feet per second square. Okay, so this is the magnitude of the velocity at point P. Okay, and then this is the magnitude of the acceleration at point P.